Alright everyone, so today we're going to be doing 4.1, which is going to be graphing quadratic, standard, and vertex form. So let's talk a little bit about what a quadratic is. A quadratic is a polynomial of the second degree, so a 2-degree polynomial, that can be written in standard form. And standard form is known by f of x equals ax squared plus bx plus c. Now, this form can also be a y instead of the f of x, just so you know. So you can see it either way. Now, if we look at a quadratic, the graph of a quadratic is called a parabola. So when you hear me refer to a parabola, I'm talking about the graph of the quadratic, okay? So, a few important key features you need to know about a quadratic that I might ask you on a quiz. The y-intercept, and when your quadratic's in standard form, that's known as the c, and it's where we hit the y-axis. And then we have our x-intercepts. We'll talk more about those, but those are basically where we hit the x-axis, okay? We have the axis of symmetry. This is a vertical line that cuts your quadratic into two equal pieces. And then we have the reflection of the y-intercept, and that's the point on the other side that is equidistant from the axis of symmetry. And then, of course, the vertex. The vertex is either the maximum or the minimum of your graph, and it will be where the axis of symmetry and the graph meet, okay? So a quadratic can have a maximum or a minimum. It will never simultaneously have both. So a maximum occurs when the quadratic is a frowny face, and the minimum occurs when the quadratic is a smiley face. And those both always occur at the vertex. So here's the steps to graphing your quadratic in standard form. You have to ensure that your quadratic actually is in standard form. You want to identify your y-intercept, which will always be 0, c. And you want to find your axis of symmetry. So the formula for axis of symmetry is x equals negative b over 2a. That's a formula you use to calculate it. And then you evaluate the function at that value, and then use a table generator, basically the table to generate the rest of the points. So let's go ahead and try a problem together, and then I am going to show you on Desmos how to do this as well. So basically every single graph that we're going to be doing today, I'm going to be adding an extra value into the table, just so you know. And the reason for that is I think it's easier to learn that way, so I'm just going to put an extra value in. So with that being said, first thing you want to check is this quadratic in standard form? No. What would its standard form be?
4x squared minus 8x plus 1.
Good. 4x squared minus 8x plus 1. So notice I have to rearrange it into standard form, and that's really common. You have to make sure the x squared term comes first, then the x term, and then the constant. So now that I've rearranged it, what's the a value?
4.
The b is? Negative 8, and the c is?
1.
Good. The formula you then use is x equals negative b over 2a. So in this formula, you're going to plug the values in. That's going to be x equals. Now notice your b is already negative, so what's going to happen when I plug it in for the negative?
Positive.
Good, it's going to become positive over 2 times your a,
8.
which is 8 over 8, which is what?
1.
1. So that's going to be the middle of your table, okay, that x value. Now what you would then do, if you're doing this all by hand, you would then take that x value and plug it into the function. So I'm going to take my function, where I'm going to replace every single x with the x value I just found. And then I just simplify. So 1 squared is 1, 1 times 4 is 4, minus 1 times 8, which is 8, plus 1. That simplifies to give me negative 3, right? So what this is right here what we just found, this is the vertex, okay? And the vertex is where the graph turns around. It changes its direction, okay? So once you find the vertex, this is where you know where to put the rest of the values into your table. So the easiest way to do the table is to go back 2 values and forward 2 values. So what's 1 smaller than 1?
0.
What goes here? -1. Here is going to be
2.
and
Great.
good. So to get the corresponding y values, or f of x values, you would just go ahead normally and plug these values into this function, right? But that's going to take a while. So here's a little bit of a trick I have for you. So if you're on Desmos, what you're going to do is you go to desmos.com, you click graph, and then you can type the function in right here. So you just type in the function, and we're going to do a whole little activity where you practice using Desmos.
Equal to 8x squared.
Oh, I see. You're right. I forgot to put the one that I rearranged it. There we go. Got to take out the square on that, yeah. Okay, so I just typed in the equation for the function, and if you scroll out a little bit, you can see the graph of it. But more importantly, we have this button right here. It says Edit List. If you click on it and click this little table, a table will come up, and this table will generate the values for you. So I'll zoom in a little bit on my projector screen so you can see it better. But you know those values we determined that would go into the table right here? We're going to put those in here. So we said it would be -1. We said it would be 0, 1, 2, and 3. So does everyone understand why I changed the values the way I did?
Yeah.
Okay. So now that we have that, we now can put these values into our table. See how it did all the math for us? So we don't have to do all that plugging in. So I'm going to zoom out and I'll type it into mine now that I've showed you how to do it. So it's going to be 13, positive 13, 1, 1, and 13. And you're going to notice something special about this. You see these values here and these values here. Good, they match because of the symmetry on the graph. So very important there. So now we're going to go ahead and graph these values, any that we can graph. So I can't graph -113 because my graph only goes up to 10. So I'm going to just jump to the next one, which is going to be at 0, 1. And then I have one at 1, -3. And then I have one at 2, 1. So there's only really 3 values I can actually fit on this graph. From here I'm going to connect them into this U shape. It's going to be a really skinny U.
Right.
So the x value is the f of x and, or no, so the y value is the f of x.
Exactly. F of x, anytime you see it in math, it really just means the y. It's just function notation versus equation notation. And your axis of symmetry is x equals 1, as we found it to be earlier, right? So the equation for any type of vertical line will always be x equals a number. And now once you have identified that, you can go ahead and I'm going to slide over so we can go ahead and find the key features. So this graph opens what way?
Upward.
Good. Axis of symmetry is
1.
x equals 1. The y-intercept is 0, c, which is 0, 1, 0, c. Domain for any quadratic is -infinity to +infinity. Now the range is where it gets a little bit different. So your range is always going to go to infinity in one direction, depending on the specific graph. Now this graph goes up forever, but it starts, what's the smallest value it takes in the y here?
-3.
Good, so it goes from -3 to +infinity. And that's because that's the lowest value that it takes right there. And you would close this with a curved bracket. And does this, yes, go ahead. Does this graph have a maximum or a minimum?
Minimum.
Good. And this minimum is -3, and it occurs at 1. So this is always going to be the, basically, the y-coordinate of your vertex, and this is always going to be the x-coordinate of your vertex, okay? So does anyone have any questions about that so far? Are we ready to try the next problem, or does anyone need a little more time on this one? Okay. So let's move on then. I'm going to go ahead and try number 2. So first thing I look at is this equation in standard form? Yes, it is. So we can copy over the A, the B, and the C, okay? Now that we've identified that, we're going to use our formula, x equals -b over 2a. My b is going to be -2 because it changes sign. 2 times -1/2. And if you do the math, that comes out to be -2 over -1, which is what?
-1. Oh.
So this comes out to be -2 over -1, which is 2, right? So does anyone have any questions about how we got 2?
I have a question, but it's not about how we got to.
Oh, what's your question?
So what does the C value do? Why do we have it as like C, but it doesn't have anything in the formula? Is that for later or?
Yeah, it's not in this formula, but later on we use it because it's the y-intercept.
I see, alright.
Yeah. Because the y-intercept is 0, C. Alright, does anybody see any errors in my axis symmetry here? I'm just triple checking it here. That's right?
Pretty sure I didn't notice anything.
When you have 1/2, you divide it, right?
When you multiply 2 times 1/2, it's like basically,
Division, right?
it's like 2 divided by 2, yeah.
Yeah.
Okay.
Yeah, I think you're right.
Okay. I don't know why, sometimes I do these problems so many times a day that like it starts like,
No, I get stuck up on them too all the time. Like, oh, that doesn't seem right.
because like if I do it in multiple classes, I start thinking I got a different number, and then I'm like, wait, I think that was a different problem, so I don't know, it just trips me up sometimes. So the 2 goes in the middle of the table, and then we have to find its corresponding y value by plugging that back into the function. So I just took my value right here and I plugged it into the function, okay? So now I do the math. What is 2 to the second power?
4.
4. What's 4 times -1/2? -2. Plus 4 minus 1. That comes out to be 3 minus 1, which is 1. So is that,
It comes out to be 2 minus 1.
yeah. So is everyone good with that, how I got that? Okay. So now I'm going to type this into Desmos because I'm going to let Desmos do the table for us. So does everyone see when I go into Desmos, I actually go in and change the table?
It's not popular.
What? Oh, I can't show it yet because the people are still copying this. It's kind of, yeah. So I put this in right here, and I type all my values into the table. I'm going to do that while you are still getting this last bit down. Alright, so if we look at the table, as you can see, I put in the equation that we have, and then I changed my table values. I changed it to have 2 in the middle, and then I went back 2 values and forward 2 values. Does everyone see that? And I do that by just clicking here and typing those in. So I'm going to do that with you right here. That's going to be 1, 0, 3, and 4. And then this comes out to be 0.5, negative 1, 0.5, and negative 1. So we're going to make sure these match, which they do. So it looks like we did our vertex correctly because the values around it match each other. And now we're going to go ahead and graph it on the coordinate plane. So we have 2, 1. We have 1.5, 3.5, 0, negative 1, and then 4, negative 1. So I just connect the dots, and then my axis of symmetry goes right through the middle. Okay. So does this open up or down?
Down.
Axis of symmetry is? So here is where the y-intercept, the c value, comes in. What's the c value? Good. That's your y-intercept. Okay? Your domain for any quadratic is negative infinity to positive infinity. And the range is based on basically this function is going down forever. So this range is going to be from negative infinity until it gets to the positive 1. Good. So your range, whether it be on one left end or the right end of the interval, will always include this value right here, the y, of your vertex. So this graph has a at 1, yeah, you're right. So it has a maximum of 1 at the x value of 2. Does everyone understand that so far? All right. So now we're going to talk about what a vertex is, or vertex form. Alright, is everyone ready to proceed? Alright, so let's talk a little bit about vertex form. So vertex form is basically when a quadratic is in the form f of x is equal to a times x minus h squared plus k. And the vertex form is really useful because it allows us to identify the vertex without actually doing any type of math, okay? So in this case, with this one here, we always can also find the a value. Now the important thing about when you have vertex form is when you take the h out of the equation, it's actually going to change sign. Because notice the formula itself is negative right here. Yes?
Wouldn't it be the absolute stuff? Why is it good?
This is when you're doing an absolute value equation, which looks really, really similar. So I'm thinking you're thinking of that, which is a times the absolute value of x minus h, absolute value plus k. They're just really similar in equation. Yeah, a lot of people were asking me about that. So let's go ahead and find the vertex. So what you do is you take whatever this number is and you change it to the opposite sign. And then this value right here is going to stay as is. So that's how you find the vertex. And then your a value is the value right out front, which is 2. So does everybody see how the h changes sign but everything else does not? In math, in any math or any science class you're taking, when you see the formula itself has a negative sign in it, that means that that variable is going to change sign when you take it out. Okay, that's just a mathematical rule. So now when we go ahead to do the next one, the vertex is going to be -3, -1, and my a value is going to be -4. So what's the vertex going to be for 5?
4, 2,
Good. And the a?
-5.
Good job. So how does everyone feel about identifying the vertex and the a value? Good? You ready to try a math problem with it where we graph? Alright. So this equation is in vertex form. So the good news about vertex form is you don't have to do any formula to find the axis of symmetry or the vertex. It's all right here. So what do we know our vertex is?
-5, 2.
Good. -5, 2. And that's going to be the middle of the table. So with that being said, what's going to be the x value here?
-6.
Yeah, -7. What about here?
-4.
Uh-huh.
-2.
Good. How's everyone feel about that? Good? Okay, so we basically just backtrack and forward track. So from here, you could go ahead and type these all in, and then, or just go ahead and do the mental math, or like, plug it in. But the easier way would be to use Desmos here. So I'm going to show you how I type this in on Desmos. So I pull over Desmos, and I just type in f of x (x plus 5), and I allow you to use this on the quizzes and everything, so it's really good to learn. So once I type that in, notice the Desmos always defaults the table to some weird values, so we have to change it to the values we want, which are -7, -6, -5, -4, -3, and -2. And we don't care about these ones down here. We don't need those. So now that we have that, we basically have our whole table. I think I put an extra value in, but it's fine. So I will copy this over for you so you can see it better, because I know it's tiny. So this is -2, 1, 1, and -2. So once you have those values, you're going to plot them on the graph. So we got -7, -2, -6, 1, -5, 2, -4, 1, -3, -2, and then you're going to connect them.
-7, -2, wouldn't that be in the way a lot lower?
No, why?
Oh wait, I was going more. Oh, I was just never mind.
Oh, you were thinking it went by 2. I see.
I was going by the y-axis and the x and stuff.
Oh. You had me worried. I was like, did I do something? Okay. So that's going to be x equals -5. And now we're going to identify domain and range. So the domain for any quadratic is what?
-∞, +∞.
Good. And the range for this one?
-∞ to 2.
Good. -∞ to 2. And remember, we use that square bracket, the one with the hard edges, when we're dealing with the endpoint of the bracket. Okay? So now from here, what is the a value of this one?
-1.
-1. And I got that right from here. Okay?
Wait, how did we get -1?
So -1 is basically just the a value that is in front of the
Okay, so the a value, okay, I get it. Sorry, on the other ones, it's
no, it's because the other ones had an actual number there, but when it's not, when there's no number there, it's just an implied 1.
okay.
Okay? So now for the next one, this quadratic opens down. Good. It opens downward, as you can see. So now the axis of symmetry is x equals -5. And what is the vertex of this?
-5, 2.
Good, -5, comma 2. So here's where we get into the x-intercepts. So with the x-intercepts, the easiest way to find these is to look at Desmos. So if I pull up my Desmos right here, I have two x-intercepts. So what you do is you find where we cross the x-axis and you click on those. And those will tell you what the x-intercepts are. Does everyone see that on the graph where I found those? So I just click here and here because that's where we cross the x-axis, okay? So that's going to give me the x-intercepts at -6.4, comma 0, and -3.6, comma 0. And you can just round to the tenths place. That's fine with me. Now to find the y-intercept, it's really similar, the procedure. So I zoom out on my graph a little bit like this, and I scroll down, I move down until I see I cross this axis right here, the y-axis. I click, and that gives me the point, which is at 0, comma -23. Does this graph have a maximum or a minimum?
Maximum
Good, and the maximum is?
2,
Which occurs at?
-5.
-5. Alright, so this is where it's really important you have to practice using Desmos, and we'll do some practice material this week. Alright, so this is the last one we're going to do together in class, and then you'll have a few problems for practice for homework. So the middle of the table is going to be your vertex, which is at 3, -4. Does everyone see how I got that? I'll go a little bit quicker through this one now that we've learned the procedure. And then this is going to be 2, 1, 4, and 5. Remember, this is the vertex. So once we have that information, I will type my equation into Desmos. And if you didn't have Desmos for some reason, to get those values, you would just plug them in for x into the equation. Does everyone understand that, how that works? Okay. So once we have our table, I'll go ahead and I'll type in the x values that I want, which are going to be 1 through 5. And I have that now, so I'll show you what they are. It's going to come out to be 4, -2, -2, and 4. And once you have those, you're going to go ahead and graph them. So we have 1, 4. We have 2, -2. We have 3, -4. 4, -2. And 5, 4. You connect them to make the U shape that it should connect to. Best you can, doesn't have to be perfect. And then you draw in your axis of symmetry, which cuts it directly in half. And the axis of symmetry is always x equals the x coordinate of the vertex. The domain for every quadratic function is -infinity to +infinity. And the range, in this case, it starts at sorry, I can't write it sideways on mine, so I just am writing it down here. -4 to +infinity. Remember that your range will always include this value, whether it be on the left endpoint or the right, based on the graph itself, if the graph's opening upward or downward. Now that we have that, we're going to go ahead and identify the key features. What did we say the A value was here?
2.
Good. It opens.
up,
Axis of symmetry we found earlier. Vertex, same thing. Vertex is 3, -4. And once we have those two items, we'll go ahead and look at the graph for the x and the y-intercepts. Now what I want you all to know about x and y-intercepts is that anytime you want to find these in math, you can always plug in 0 for the opposite variable. But in this case, let's go ahead and look at the graph and see what it says. So I have my graph here. and I will show you all what it looks like. So my x-intercepts occur where I cross the x-axis, which is in these two spots, okay? Right here and right here. So we're going to round those to the tens place, 1.6 comma 0 and 4.4 comma 0. And I will allow you to use this on all quizzes, whether we quiz in class or at home. You will be allowed to use Desmos, okay? So we're going to zoom out. And as you can see, we cross the y-axis at 0, comma 14. And this graph has a minimum. And the minimum is -4 at 3. Good. All right.